we continue a little bit from where we left off. It's been how many streams already? It's been I forgot. This is number 6 or something, or 7. I forgot. So yeah, we can continue where we left off with the previous Spout2, PipeWire, lip funnel, all that video sharing story on Linux. So let me say hi to everyone before we start. Why? I just realized, like, why does it think I'm... why does my tracking think I'm closing my eyes when I'm not? Huh? It's just the angle problem. Hold on. Let's just move the tracking up instead. That might be better. Maybe that works. I'm not sure if that's better, but we try it. Oh no. I locked my phone. Oh, it's always junk. It's always junk. Okay, are we back? Are we back? Yes, there. Okay. I think I'm gonna have to adjust that tracking. Hello, everyone! Alright, so let's get started. Hello, Skipper, hello, Imagine, hello, Zone Tough, hello, Penguin Operator, hello, Nick Chan, hello, Clover, hello, Mads Web, hello, Devixan, hello, hello, Narikami, hello, Keter Codes, hello, Nick Chan, I think I said that. I think that's around. Hello, Nerd Inferno, hello, Conan, no, Conan's here. So, Hoshino, yes, it's Hoshino. I don't know who the other person is. I've always been Hoshino Lina. Okay. Hey, Dram. So yeah, we left off last time with a lot of confusion over how PipeWire handles buffers, and I think I know that what I was trying to do is not going to work anymore. So we're gonna just do it the proper way, and hopefully that's gonna work. So let me explain what's going on. So I think my machines will be good. All right. So what we were trying to figure out this whole PipeWire stuff, and we don't need async anymore. I think. Yeah, let's just throw it away. Okay. We're going to do our own async-ish thing. So, what we were trying to do is, we have a function to get buffers from PipeWire and send buffers to PipeWire, and my original assumption was that I could just, grab buffers and send buffers, whenever I want, and PipeWire would just queue them, and then, send them one by one when the graph is running. Apparently that doesn't work. I think PipeWire really wants us to do the buffer queuing and dequeuing inside the process function. Even though the functions are thread safe, the issue is that PipeWire is not... Basically, let me show you what the problem is. What I found out yesterday. Not yesterday, a week ago. The issue is that when PipeWire manages buffers, right? Let's say we have a queue, right? And it's 1, 2, 3, 4, 5. 1, 2, 3, 4 buffers, right? And let's say we grab all of the buffers, right? And so all the buffers are dequeued. And then we enqueue the first buffer, right? And so PipeWire is gonna grab the first buffer and try to send it to the destination. So let's say that we are running slowly. Wait, let me think about this. Am I doing this right? No, sorry. So let's say, yeah, they're all dequeued, right? So on the next round, we are going to try to dequeue buffer 1 again. And these buffers are still all busy, right? So we dequeue buffer 1, but buffer 1 is busy. So it returns to the... Am I doing this right? I'm not even sure if I'm doing this right. No, that's not right. Sorry. It happens when they're busy on the destination. So once these buffers are all enqueued, let's say, right? They're ready to be sent to the destination stream. PipeWire is going to eventually send them to the destination, right? So when we are in the loop, we're trying to grab buffer 1 and it's busy, right? There is no buffer 1. So it returns. That's fine. But then the destination uses buffer 1, right? So now the buffer 1 is like these buffers have been sent to the destination. Let's say buffer 1, 2, and have been sent to the destination, right? So PipeWire sends buffer 1, and now it's busy. So now the buffer is at the destination, but it's busy. When PipeWire tries to grab a buffer for us to use on the next round, it looks for buffer 1 and says, oh, it's busy. I'm going to send it to the back of the queue. And then it tries to grab buffer 2 on the next round, on the next loop, and it says, oh, it's busy. I'm going to send it back to the end of the queue. The problem is that even if this buffer 1 becomes not busy, if buffer 3 has been sent out already, so this is busy, the next time on the loop, it's going to try to grab buffer 3, and it's going to say, oh, it's busy, so I'm going to send it to the end of the queue, even though buffer 2 might already be free. So basically, PipeWire doesn't look for a free buffer. It just grabs the, like it's a FIFO, right? The least recently sent buffer that was busy, right? So if you have this situation, right, PipeWire is going to look at this buffer and say, oh, it's busy, go back. And then the next time around, it's going to say, look at this buffer, and it's busy, and go back. But this buffer might have been freed by then. And the next time around, it's going to look at this buffer and say, oh, it's busy. Still, still nothing. But then we actually have 2 free buffers. And so then by the time we actually reach a buffer that is free, we've dropped frames, right? I would call this a possibly a PipeWire bug or a PipeWire misfeature. But the way you resolve this is by always doing buffer queuing in the process function, because the process function is when buffers are sent to the destination. So if you always grab buffer in the process function, it should never be, in theory, it should never be busy if the previous process function has run, right? And we have enough buffers. So this only happens when we actually use all the buffers. If we don't use all the buffers, we never get into this weird situation. And to not use all the buffers, we have to synchronize the buffers that get sent. And that happens in the process function. It's all really weird. Yeah, we're going to just do that. So for that, we're going to change the API again. We had this queuing thing again. So instead of final stream set queuing, I'm going to call this final stream set mode. And this is going to configure how the basically how the queuing works. And we're going to have multiple modes because there's a few modes that make sense. So one mode, funnel, is funnel async. This is going to be the default mode, and that is what you use when you are generating frames at your own pace and you want to just send them. And if they get dropped or they get duplicated, that's like none of your business. Also, this means that if the other end is receiving frames and itself is asynchronous, then it can choose to synchronize with what you are doing. So you can send frames as fast as you want, and if the other end can receive them at that rate, it can synchronize and get all of them and like wait for them. So it means you can optionally be a driver, but in general, it's meant for applications where you are just running like at the screen refresh rate and you just want to send frames, and whatever happens, happens. So another mode we would want to have is funnel. Let's call this. I think we want to call it something like funnel. Let me think about this. So more like funnels. Think. Let's call it funnel buffered. So in this mode, we can render a frame, and then we will wait for the frame to be consumed. So we will render a frame ahead of time, and then when the destination is ready to consume that frame, it will do so, and then we will be able to start rendering a new frame. Actually, no. We can render a frame and queue it for consumption, and then we can render another frame. So we have like a double buffering thing, right? And so this is useful if rendering a frame takes a long time. So you want to have at least a 1 frame queue so the destination can consume the frames and you're not blocking both sides. And finally, we could have something called funnel sync. So in the sync mode, we will, let me think about this for a sec. Actually, no, we want 3 modes. We want funnel buffered. Basically, it depends on where you sync. So in one mode, we can render a frame, queue it for consumption, and then render another frame right immediately. And we only block when we want to send the next frame. Another option is that we send the frame, and then we block when we start rendering a new frame. So this is a subtle difference. It depends on which function you're blocking in. So that means that you would never have 2 buffers. Like when one frame is consumed, you start rendering the next frame, but only when it's consumed. And then the third mode is when you actually render the frames within the PipeWire process, graph process cycle. So in that mode, you would have the lowest possible latency, but you would want to have the rendering be as, as fast as possible. So this only makes really sense when you are, probably when you're not really rendering much, when you're just copying. So, I need names for these modes. I guess it'd be something like double buffered, single buffered, and then the last one would be like funnel, something like funnel unlocked or something like locked or something like that. It's like funnel real time. It doesn't have to be real time in terms of the CPU, but it's like or even just funnel sync would make sense. Yeah. So you have async, double buffered, single buffered, and sync. And we probably want some documentation for these. So we say funnel async. Is this how you do? Is this how you do the doxy and stuff for enums? I'm not sure, but I think that I don't know. Whatever. Yeah, something like that. And we'll call this let's see, this one has the lowest. Yeah, something like that. Is it double buffered or triple buffered? Let me think about this. With double buffering, isn't the screen and then you render again? It's more like we actually have more buffers, so I guess it's more like triple buffering because you send one and then you grab another buffer, but the buffer can be sent out and you're still rendering. Yeah, essentially it can be triple buffered. Oh, let's also set the frame rate here. So this is going to be produced frame synchronously to the consumer. Let's reformat this a bit. So in this mode, after a frame is produced, it is queued to be sent out to the consumer in the next PipeWire process cycle, and you may immediately dequeue a new buffer to start rendering the next frame. The funnel will block at funnel stream in queue. Where does this fit? Yes, it kind of fits. Something like that. in this mode. Funnel streaming queue will never block. And we can just say that if the stream is paused or whatever, that just throws this buffer away. Hello, everyone. And then finally, I don't know if I'm going to implement the sync one yet, but I want to have it here for later. Okay, something like that. And I need to take a very quick break. Sorry, bathroom break. Thank you, Mario. Thank you so much for the memberships. Thank you so much. Okay, I'm gonna take a very quick break. I think this makes sense. This approach makes sense, and I think it's gonna work given what we learned all the previous streams. So I don't know if I'm gonna implement all these modes today. I don't think I care too much about sync right now. Sync might be nice for the Spout2 stuff, but it's also gonna work fine with single buffered. It just means you get one more frame of latency. So I'll be right back, and then we'll get to redoing the API one more time to make this work, and see how it goes. Be right back. So I think this is going to make sense. Let's now change the API so it uses these things properly. So we have set mode. And I think we can just allow this to be changed at any time. Mode. I think that's going to be fine. We might need to audit to make sure that this can only be changed like some corner cases, but I think it's okay in general to allow it to be changed while the stream is running. So we need to store this somewhere. So in the configuration here, instead of buffers, it's called mode. And I think the buffers, yeah, I'm just going to leave that here in case that is ever useful to change the number of buffers. But I think we might want to, okay, so we might want to actually think about how we configure the buffers here. So set now stream set mode enum mode. So the let me think about this. Def min max. I can put this mode outside actually. So let's think about how many buffers we need. Because I have this double buffering thing in OBS, I think we need 2 buffers for OBS to potentially use. And then for the async mode, we need to be able to grab a buffer and have it queued for sending. So we need at least 3 buffers. No, we need 4 buffers. 2 that OBS might have double buffered, 1 that is being produced right now, and 1 that is queued for sending in the next process cycle. That means we need 4 buffers for async mode. Actually, I think for all modes we need 4 buffers except sync. Actually, no. Single buffered and sync need 3 buffers. The others need 4 buffers. So, but that is if OBS has double buffering, which is not necessarily required. So everything is going to need. Yeah, okay. Let's do a switch mode. In case of async and double buffered, then we need to have 1 buffer in flight, 1 buffer queued, and so at the very least we need minimum of 2 buffers. But let's assume the consumer is going to at least grab 1 buffer and use it outside the process cycle. So let's say minimum 3 buffers to be safe. And the default should be 4 so that the OBS thing works. And max honestly can be anything, but we can just say max 8 so that if a consumer has a reason to have more buffers, they can ask for more. Honestly, this is kind of a little broken in PipeWire because if you think about it, what you really want to have is how many buffers does the producer need, how many buffers does the consumer need, and then you add them together. And that's what you really want. But PipeWire only really supports this single setting. So you have that in single buffered mode and in sync mode. Then we would have a minimum of 2 buffers, presuming the consumer is going to use 1, and a default of 3. Because we probably want at least 3 so that OBS can have 2 running, and then we have 1 that has gone through that is in flight and the producer. I think that makes sense. Well, you don't want to have too many buffers because this is memory, right? Each of these is a whole frame. So if you're doing like 4K, this is a non-trivial amount of memory. But yeah. I think this makes sense for what we're doing here. Okay. And let's do the thing here. Okay. That, I think that makes sense. So now, in configure here, we're just going to use, we're not going to use the async flag because I don't think that actually did anything useful. And now we need to actually figure out how we handle these buffers. So what we want to do is we need to have at least 1 buffer that is ready to be sent. So we need a in the stream a like next buffer thing, because now we're going to use the process callback to actually grab buffers. And I think we also want to do okay, so let's look at some things here. We want to do this check in dequeue. So in dequeue, we would lock the thread loop because that's our lock essentially, and then we say if stream cur where is this stuff? Config mode. If we are in async mode, then if we don't have a buffer, we just don't have a buffer. So if first we check if stream next buffer and stream next buffer PW buffer. That means that buffer is stale because there was a reconfiguration. So we just want to free it in that case and drop it. That's just a sanity check there. And then if we don't have a buffer, if we are in async mode, then we just return with no buffer. And also, we're not doing this blocking argument anymore because that is implied by the mode. So we're just going to drop that. And we should check that if there's a because we only support dequeuing one buffer at a time right now, I think. So to handle that, we probably want to have a buffers in use thing here. So in enqueue with assert stream buffers in use. Let's also do a check for buff in here. And do a check for buffers. Okay, buffers dequeued. Are you decrement that? We have to change this code later anyway, and then in return we want to do the same tests. I think we don't really need these prints. And eventually I want to have the better logging than this anyway, but this is kind of temporary for now. So assert that we have some dequeued buffers. And then, so here we want to check for that. If stream buffers dequeued is greater than 0, I'm gonna just print an error here. There might be a use case for that at some point, but for now we're just gonna do that. So then we look for next buffer. If we don't have next buffer, if it's async, then we return no buffer. So just return success but no buffer. Otherwise, actually, this should be a while loop because we're basically doing this do while loop here. So we don't have a buffer. If we are in async mode, then let's think about what the mode should be. So in async mode, we just return. In double buffered mode, this means that this means we don't have enough buffers dequeued. So if we always don't dequeue buffers in the process function, then we kind of necessarily have to be able to have more than one next buffer, because the first round after this starts running, the first loop, you would want to have at least 2. I guess we kind of want a queue in here. Yeah, we kind of want a queue in here. I mean, you gotta drop a few frames in the beginning anyway. But yeah, I guess we want to dequeue more than one buffer at once. So in that case, yeah, we do actually want to list a, yeah, we want a queue of buffers that are ready. How do I want to do that? Buffers. Do you want to use a linked list? No, I don't really want to use a linked list. And we have a, there was an SPA. There are SPA functions for lists, I think. Might be able to just use some of that. Oh no, PipeWire. Please do not. I guess a linked list would work. But then we need to also have a count of the list. Do we want a list or an array? I think there's other things we can use in utilities. There's list, ring buffer. Yeah, this is for like raw ring buffers. Yeah, I guess we can use a linked list. Okay. Do I need to get a buffer? I mean, I can technically just grab things from PipeWire anyway. Next buffer is most useful when... No, hold on. I think I can just grab the buffers early. I think the problem is just sending buffers. Like too many ahead of time. I think I don't really need this. I think what I really want is just... Not a next buffer, a... like... pending buffer. Yeah, that makes sense. Because I think we can actually dequeue buffers safely outside of PipeWire as long as we don't do it too quickly. And then we don't need a list. I think that's gonna work. So in this case, it wouldn't be next buffer. This can just go away. So we check the mode. If the mode is... we still have this checked just to make sure. If the mode is async, then we always want to just grab a buffer. The only thing is that PipeWire, when you try to dequeue a buffer, it uses the most recent one. You don't want it to fail. But it should never fail. However, if we are returning... Oh, this is a little interesting. Okay, so does PipeWire return buffers to the back of the list or the front of the list? Stream. Yeah, so if we are qpop, need to check these functions in PipeWire. Oh, that says in here, okay. This is a ring buffer, okay. This is a list of IDs. Read index. What does this be a ring buffer get read index? Oh, so this is just like a ring buffer management thing. It doesn't actually hold the data. It's just it's literally just a And where's the size? There's no size. Use buffers. Clear buffers. And then for every buffer, it pushes it into dequeued if it's recycled. Okay, so push is basically a write into a ring buffer. Pop is basically a read from a ring buffer. And then there was a like push front or something. Push front is a undo on the ring buffer. Okay, so it's push and pop are a little of a misnomer. What this is actually doing is return buffer is actually undoing it. Dequeue buffer is pushing. Okay, so that makes sense. And then queue buffer is pushing it to queued, which is fine. And then the problem here, this queue push should be push in front, because if the buffer is busy, you want to retry with that buffer, not the next one. So this is actually kind of a bug, but hopefully we never hit that. And return buffer is push front, which makes sense. So yeah, so that's fine then. Okay, that makes sense. So we could use the same ring buffers setup for our buffers. And in that case, we only need an array with the maximum number of buffers to hold the allocations, which is a bit easier than a list. So in this case, we can just grab as many buffers as we want, as long as we aren't... It's basically when we run out of buffers that we are in trouble. So if we grab 2 buffers, that's fine, because they're gone, and the next time they're going to come in the other end of the ring buffer anyway, regardless of the... Okay, yeah, so that's fine. That should be fine then. I think we can just... then we need a single pending buffer. We're never gonna have more than one pending buffer anyway. Okay, that's fine then. So, in this case, we can just grab a buffer the way we were doing it before. So go back to this. Try dequeue. It's all messy now. I don't need this. So we try to dequeue a buffer, but we don't really want to block here. Where we want to block is if we have a buffer, yeah, depending on the mode. So what we do is, we are locked. If we have more buffers dequeued, we just... Oh, this has to be unlock return. Ian val. And then we can try to grab a buffer. What happens here then is... in async mode, if we have no buffers, or the stream is stopped or whatever, we can just return nothing. If the stream is not running, we want to just return nothing, even if we have buffers available. So we actually need to check what the state of the stream is in this case, because we don't want to queue them all into PipeWire. So in async mode, we want to check we have the stream state somewhere here. The state changed. I think this is PipeWire stream get something. Stream. There's probably a get state or something. Yeah, get state. And the possible states are error, unconnected, connecting, pause, streaming. So essentially anything but streaming is if state does not equal streaming, then if this is async mode, we just return. It should be a while. So we wait for it to be streaming first. In async mode, we just return 0 with no buffer. So nothing to do in that case. Otherwise, we block until we do the loop wait dance. And continue. And we need to actually get the state here. Okay. Let's do a print in there. Now we are streaming, so we should be able to have buffers ready. So it should be safe to grab a buffer in this case. So in this case, we just go straight to try dequeue. And this should never fail if we are here. But before we get here, we want to make sure that we do the blocking we wanted to before that. So in sync mode, we are not implementing sync mode quite yet. In single buffered mode, yeah, we want to wait for there to be no buffer. in single buffer node, we want to make sure the previous buffer was already sent. So in that case, pending buffer, if stream pending buffer exists, actually while for pending frame, and we just did the thread loop wait thing, and that's it. So the only thing here is that we need to make sure we always clear this if there is a mode change or something like that, because in that case, we definitely don't want to maybe just clear this to null, because that buffer is not sent to PipeWire yet, but not going to send. I think we can just free it. Wait, no, let me think. You would want to just essentially return that buffer in that case. Yeah, we want to do a funnel stream return on that if it's set. So we lock it if stream pending buffer just return that. What? Funnel stream. Is that not defined? It is. Why? What? Something with the speed is a little weird here. I don't know. Okay, anyway. If we have a pending buffer, return that. Unless there's no stream, but there should be. Yeah, because if a buffer is being destroyed and it's being dequeued, it won't be freed. So this is to make sure we free the buffer that is not sent to PipeWire yet. And we would consider that they would consider that buffer dequeued. Actually, no, we can just do the dequeued dance. Yeah, actually, we don't need that. What we need is if it's not dequeued, we free and remove buffer. If buffer equals stream, is it pending buffer? What did I call it? What did I call it? Pending buffer. And then we need stream in here. On remove buffer. Yeah, so when we remove a buffer, if it's pending, we just throw it away. And then we're fine. Just put a in here actually. I think PipeWire should free all the buffers whenever that happens, so that should be safe. And return ended in queue. You okay? Okay, so back to the dequeue function. Oh yeah, and if we stop the stream, we want to also get rid of the pending buffer. So there's the where's the mode thing? Here, stream error, pause, streaming, connecting, unconnecting. So if there's a pending buffer, we just clear it. Actually, we can just do that, because in that case the buffer is just considered not dequeued. Oh, but PipeWire is gonna. No, we need to return it. Do we need to return it? Yeah. Let's do a function here. Static void reset buffers. So we're probably gonna use that more than once. So if we are not streaming and we have any pending buffers, we just clear it. Not in streaming. If we're streaming, we're good. If we are connecting or unconnected, yeah. And we might want to do some other checks here and reset buffers. We probably also want to call it on reconfigure. Yes, if we're calling stream configure, well, it depends on what changed though. But if we are updating all the params and everything, we probably want to just do that. Yeah. So if you reconfigure the stream, we're gonna drop a frame. I guess I'm actually not sure. Does this cause a whole reconfig? It might be. No, it might not actually. So I think we want to do that in the callback. On add buffer, no. On param changed. If the format's changed, is the rate part of the formats? I'm not sure if changing the frame rate will renegotiate. It might. But I think that's going to cause all the buffers to be allocated anyway, so it should be fine. Okay, so let's leave that out. So back to this function. When we dequeue a frame, if we're not streaming and we're in async mode, just continue. Otherwise, we wait for the stream to be running. If we're running and in single buffer mode and we have a pending buffer, we wait until that to be consumed. And we did make sure that that is cleared if the stream is not streaming. So in fact, we want that to be the other way around, because if we are single buffered and we have a pending buffer, that means that the stream is streaming, because otherwise that would not be valid. And in fact, we probably want to check that in queue buffer. If we enqueue a buffer and we are not streaming, if we're not streaming, then we just drop it. And return, let's see. E again or something like that. I'll probably check that before the PW buffer thing, actually. Yeah, that makes sense. Okay. So if we are streaming, then check the single buffer mode first. If we have a pending buffer, wait for that to go away, then check that we are in fact streaming. If we are not, then wait until we are, unless we're in async mode. At this point, we should not have any pending buffers unless it was called technically it's possible for the pending buffer thing to happen again. But not because dequeuing multiple buffers is not supported. So in this case, and definitely in single buffer mode, that would not be supported. So that does not make sense. Let's just put an assert in there. Actually, the correct way to do this is actually just to have both of them in a single loop. So I think that makes sense. Yeah, so we wait for a fail state does not equal or mode is single buffered and we have a pending buffer. Yeah, we really want this in a single condition. That makes sense. And then if it's async, which returns 0. And this is just for debug purposes. And if we're not streaming, we better not have a pending buffer, so I might as well put an assert in there. Okay, that makes sense. And then we try to dequeue a buffer. But in this case, we could end up in a bad situation like before again. So I guess it should all be a single loop. So while not streaming and... yeah, we do all this. And then... I'm gonna do an evil go-to here. Except if it's async mode, we're gonna return that. Actually, no. I think there's... we did say in one more case... we said that in async mode or in double buffer mode, we can also do that. No, this box is not gonna return. It's not gonna return. It never fails, yeah. So we always just block in that case. If we're out of buffers in async mode, then we just return that. Otherwise, go to retry. And then it's not even a loop at this point. Yeah, this is a really evil go-to, but I think it's actually what we want. And I guess I might as well put this at the top, so we don't have to keep clearing it. Yeah, that's a really evil go-to, but I'm not sure how to structure this without that. I mean, it could just be an outer loop and then yeah, okay, it could be like this then. Do yeah, this avoids the go to. It's just a little weird. So it waits for the stream to be in the right state. Then it tries to dequeue a buffer. If we don't get a buffer, and it's not async, then repeat. Oh no, but in this case the while is not going to do that. So so we still need to wait in this case. But we need to check after the wait. So I guess we can just duplicate that. I guess we can move this to the end. Yeah, so we grab the state here, so we can drop that. Yeah, okay, this is how to do it without the crazy thing. And then we can put this PW buffer at the top. And just do it like this. So while we don't have a buffer, we check the state, and then this, instead of a while, this can be an if, right? If the stream is not in the correct state, yeah, okay, we can do it like this. If the stream is not in the correct state, if the mode is not async, if it's async, return 0. So you wait and continue. If the stream is not... If we have a buffer, then we print that, wait, and continue. Then we try to dequeue. If we don't have a buffer, print out of buffers. If async, we just give up, wait, and loop. And in this case, I guess it could just be do while. Yeah. Okay, yeah, this is a reasonable structure. Makes sense. Actually, you know what the evil C way to do this is? The evil C way to do this is actually... Okay, I'm gonna be evil. This is why C is evil. That's to do horrible things like this. While not PW buffer, and then on every iteration you wait. I'm so sorry. I can't. why I see as a horrible language, because it lets you do things like this. And then you need a break in here at the end. Make sure it doesn't actually go. It doesn't actually run the last thing again. It could also be a continue, because that's going to break again anyway. But it needs to make sure it doesn't wait. So this, I guess because we have that... Yeah, I guess it's... Sure. That makes a lot more sense. Yeah. This is why Rust has like a loop thing where you can literally just loop and then do all the conditions inside and, you know, not... and like return things from it and stuff. Okay, so now we have a final buffer, dequeue, make sure it's not dequeued. That's all good. So, that is... The DQ should be fine using the PipeWire DQ like this, as long as we only do it one at a time. And then, in async mode, though, we're just going to put it into the pending buffer. String pending buffer. So the way we do that, this is the important part. If we are not streaming, we just throw it away, return it, and throw it away. But I want to check if there is no PW buffer before that. If there's no PW buffer, then it's gone, gone, gone. Otherwise, if we're not streaming, you just return the buffer and throw it away. And then we check if there is a pending buffer. And we basically just replace it at this point. If there is a pending buffer, then it depends on the mode. So if we are in async mode, we want to replace it. In async mode, we would funnel stream return the pending buffer. In double buffered mode, we would want to wait for a Yes, this is pretty much where the interesting logic is going to be. If we are in async mode, if we have a pending buffer, then return it, and then set the pending buffer to the current buffer. And then unlock return 0. Break. If we are in double buffered mode, then while we have a pending buffer, we block. And we should never end up here if we're not streaming. Oh, we don't want to return. Actually, we don't want to ever return that because that is not a dequeued buffer. So we just want to do the PipeWire return actually. Yeah, so in return buffer, we would say if there's no PW buffer, free it, make this an int. Otherwise, just return that. What's going on here? Oh, stream. Okay. So then, going back to the dequeue function, the enqueue function, if we have a pending buffer, then just return that. And reassign it. So in this case, it's already not dequeued, so that is... Oh, the accounting there is fine. And... And yeah, that is done properly, so... So in async mode, we just return the pending one and assign it as the pending buffer again and return. If we are in double buffered mode, while we have a pending buffer, we have to wait. Thread loop wait. And we are again at a situation where this really should be a single while loop. So I'm so sorry. I'm gonna do this again. So if we don't have a PipeWire buffer, then it's gone. If the state is not streaming, then just return the. That means we do have a PipeWire buffer, so we can return it and we're gone. Otherwise, we switch mode. If we are in async mode and we have a pending buffer, return it, set it, and just return 0. And we don't need a break because that is a return. If we, in double buffered mode, if we have a pending buffer, then we continue. Otherwise, we set it as a pending buffer and return. In single buffer mode, we should not have a pending buffer. But if the mode has changed, we could end up in a situation where that happens. So we treat these two as the same thing. And then the only one that's missing is sync, which we haven't implemented yet. And that's it. And then we just are done. So for sync mode, in sync mode, what this is going to do is we're supposed to be in the middle of the process function. If we, what we would do in that case is I think there's a way to signal things from PipeWire. I think, I think I can just use the wait thing, but then there's the accept. Yeah, you can, basically what I can do is in the process function, we'll call signal. Would that release the lock? I think I have to see the implementation of this. But I think this would work. Yeah, this is a pthread cond with the loop lock, which means it's gonna release the lock. So that's actually what we want. Essentially, we would signal in the process call and then wait for the accept. And the accept would be sent in here in the buffer dequeue. So that's actually not that bad to implement. What we would do is, if we're in sync mode, if we have a pending buffer, then continue. Because that's going to be consumed. But actually, we would want to make sure we signal in that case, because if anything is waiting at that point. And then what accept is doing here is... This is a signal on accept con, okay. I think that works, yeah. So what you do is, if we have a pending buffer, we accept and continue. Otherwise, we, set a pending buffer and accept it. And then we can just put the unlock return at the end here and turn these into breaks. Yeah, that makes sense. So in async mode, we replace the pending buffer. In double and single buffer mode, we just make sure that we don't have a pending buffer and then assign it as a pending buffer. In sync mode, it's the same thing, except we send accept calls. I guess we might as well do this in all of them, actually. And then it's easy. Which means we don't actually need to do that. It would basically just be, if we're in async mode, if you're in async mode and we replace the pending buffer, and then in all the other modes, we say if we have a pending buffer, this needs to be else if in this case anyway. If we have a pending buffer, we do an accept and continue. Otherwise, we do we set it as a pending buffer and an accept. And then break because we're done. Yeah, that makes sense. And in this case, I guess we don't really need this 24 because there's only a single condition that can cause it to block, which is when we have a pending buffer. I think we can just do that in this case. Actually, no, we can just say, yeah, I think that's fine. something like that. I think this is one way to structure it. Okay, so we have in buffer, we do an accept await, and then, oh no, but then in this case, we always on a loop. So, actually, this is valid, right? Do while 0, false, and then only the continue goes up. Is that valid? Does that actually work? It just make it while once. Let's just do it like this. See, it's confusing. I'm not sure if continue evaluates the condition if it's a do while. If it's a while, it would, but anyway. This should be fine. And that means we can implement the sync mode in here too. The way sync mode would work is that we are waiting for a signal. So instead of dequeuing immediately, we would wait for a signal in the sync case. So if we're in sync mode, in this case, we always want to do at least one wait. And then make sure we are in the right mode. Yeah, I think the way we do this is basically, if we are in sync mode, we always do at least one wait, because we need to wait for the next process function. And then once that is signaled, we check the state and everything. If everything is... but in this case, if we are... We need to make sure we need to check the state first, actually. We make sure we're in the right state. And opening buffers and no nothing. First. And then we can just dequeue a buffer. We can just dequeue a buffer. me think about the synchronization here. So we can the way it processes is we dequeue a buffer, we do the process, and then so we would do dequeue buffer, then signal, wait for accept, and then yeah. So instead of dequeuing in the process function, we can just dequeue here, and we need to just make sure that we basically always do a loop wait. The only thing is that we want to make sure that we don't block the process function forever if something is out of sync. We only want to block the process function like what happens if the while the process function is running, the stream state should not be changing, I think. Yeah, I think I'm just gonna make sure we always accept everything in the error cases here, so we never, if we're not streaming, you always send an accept. Just to make sure that if anything is blocked, we don't deadlock there. And then the only tricky thing is that if we are, yeah, if we change the config, okay, then that means we need to call accept. We need to call accept basically everywhere that we are, where we are doing any management calls. So in the queue after the lock, we want to accept so that oh, so that thread can exit. How would that work? Not in DQ, sorry. In destroy, we lock the lock. Oh, and if we have multiple streams for a single context, then they're all running the same process call. Or rather, they're all running the same... Oh, okay, that's a little weird. They're all running the same loop with multiple process calls. So when one blocks for accept, it needs to be a loop on both sides until it gets a buffer or something else is broken. I get the feeling this is gonna be weird. Thread loop signal. There's a count wait, so it's just like wait. Which means the actual processing thread is blocked. And we can grab the lock, but the actual processing thread is locked. So thread count signal just signals the condition, but it doesn't yeah, I'm not sure if you're... Okay, who uses this accepting? This is... Does anyone use this in the samples? Nobody does. Does this really make sense? So when we destroy the thread loop, yeah, we need some kind of flag for we need some kind of flag for not locking in the process call when we are, at least when we're destroying things. Basically, we only want to block in the process call when the when someone has called dequeue. Yeah. Yeah, we need a flag because otherwise we could just block forever. So we need a flag in here for an internal. Dequeuing. So in dequeue here, essentially we would signal wait for accept. Yeah, so what we want to do is if stream dequeuing, if we are not dequeuing yet, That makes sense. If we are not dequeuing yet, we set it to true and continue, which means we're going to wait for the loop again. And at that point, we want to make sure we are like in process. And we're also, come to think about it, if we have this set up with the synchronous calls, we need some way to signal like an abort or something like that. Like, oh yeah, we basically would have to allow the stop function to be called from another thread, which is fine. Yeah, that just does a set active. So we just have to document that that this can be called from another thread. Sorry. No, I want this one here. So if we stop the stream from the producer, then we say set active. So how does that work? Set active. We want the second setup for this, because if the stream is not active, then we want to fail the dequeue call every time. And that's different from the stream being streaming. Is active? No, this one is active, so we need a check for that here. If the stream is not active, then always return an error. What's a good error for this? You shut down, I guess. It's Unix IO. No. shutdown, I guess, might work, but I'm not sure if that's a really common one. Shutdown, I guess. Yeah. So if we are not dequeuing, we become the only thing dequeuing. Which means the process thread will wait for us to come back. So it can't deadlock in that case. Because it means we're here. It just means I need to make sure that I signal things if we are shutting down. Every thread loop accept. And that also means that the stream stop needs to also do an accept in here. So the next question is, can this cause it to not have forward progress? Is it possible for us to release the mutex and then reacquire it without the thread at least getting a chance? I'm not sure about that one. So if the mode is funnel sync and we are not dequeuing, set it to dequeuing and continue. And then here we want to clear these. And we want to probably also do the accept just to make sure that we never nothing weird ever happens there. So only during the wait when we have dequeuing goes through here is when we can when the process callback and do the accept thing. So then we grab a buffer, which is fine because we're in that context. If we are out of buffers, then we want to do an accept. And say we're not dequeuing at that point. Because something weird has happened. Means there'll be one more wait for the process function. So I guess instead of dequeuing it, it should be called something like in process sync. Yeah, I guess just call it like sync cycle or something like that. Yeah, so once the stream is in this state, it will always do a wait if we are in sync mode. Set sync cycle, so that will make sure that when the process callback runs, it will do everything fine. Then sync cycle falls. If we're out of buffers, we just abort that. And then in queue, we also want to make sure we do the sync cycle thing every time. Actually, do we even need the sync cycle thing? I guess. It's gonna be blocked on accept every time anyway. So I guess once it's blocked, it's just gonna do an accept and then see if it gets a buffer. If it doesn't get a buffer, then whatever. And then if it gets a pending buffer, the trick thing here is that we only wait if it's not sync. Actually, no, we only wait if we are... single buffered. If we're single buffered, we're going to wait for it to be consumed. No, wait, we always... hold on. If there is a pending buffer, we always wait. Because... we always wait because then we need to put it somewhere. Sorry. The only case is when we are in single buffered node. Yeah. This blocks in dequeue until it's consumed. Yeah. So only in sync mode is when we essentially sorry, yeah, only in buffer mode we ever block in queue. Otherwise, we just always, if the queue succeeded, then in queue is gonna succeed. So the only question is what happens if the mode gets changed to sync in here while we are, say, well, we got a buffer, so even in sync mode, this just means that it would... Yeah, that just means that in sync, even in sync mode, if we have a buffer, we just want to consume it and then wait for the next cycle. And then in the next cycle, we shouldn't have a buffer, and that's when we do the whole dance with the sync cycle. So there should never be a pending buffer if we are... Should there be? No, if we finished queuing a buffer... If there's a buffer queued and then we switch to sync mode, the process callback is going to consume it once first. So we need like a sync ACK then. We need something that checks whether the sync was whether the callback is actually, yeah, okay, so sync cycle. Sync cycle pending and sync cycle active. Actually, I can just use enum. Enum this engine. Pending and active. So cycle state equals inactive, just to make sure that it knows that nothing's going on there. So we should never be in the middle of a sync cycle and trying to dequeue a buffer, because if that has happened, that means that was called again. So if we're not waiting, then we should not be in the middle of a sync cycle, because that means we have somehow gone more than one buffer. And then the process function, when it sees the waiting state, it will set it to active and do the signal. Which means we want to call that everywhere where this So it's not active. Make sure we reset this. Actually, it shouldn't matter. It should always be done. Just that it's active. Might as well reset this here just to be safe. So now we are waiting in funnel sync mode. If we did not get a buffer, then we cannot be, we have to cancel that. So cycle state inactive. Accept and continue. Okay. So that means when the process callback returns after everything is done, sync cycle would be inactive. If the process callback gets called again while it's still inactive, that means we are the producer is not fast enough, so we're dropping a buffer. Or dropping a process call, that is. Would we want to do that, or would we want to, I guess if we're out of buffers, we just drop it. But if we, once we return a buffer, yeah, I think this is the only safe way to do it. So let's do it like this. Multi-threading is hard. So in this case, that means we are in funnel sync mode, and this is waiting. If we did get a buffer, we need to... Wait, this means we are in active mode here. No, okay, so we want to do we want to wait for active, which is when the process callback has done its thing. Yes, I didn't know assert. So we just wait for the active. And then, yeah, if there's no buffer, we just drop that cycle. Okay, so now, so that means we should be in active mode, and then we are, when we enqueue, we should be in, if we're in sync mode and we're not active, we probably just want to drop it. That could happen if the something has happened to the stream between DQ and NQ. In that case, it's basically east tail. And make sure we don't have a pending buffer here. This should never happen. And we set this to inactive. Because we are completing the sync cycle. And so then the process callback will see a buffer and use it. Yeah, I think that mostly makes sense. So then finally, we need to look at the process callback. And that's the on process here. So, and this is where we're now doing the queuing. Because we removed the enqueue, the stream, we need the stream and enqueue buffer there. So on process, if the stream is not active, then just return. Nothing to do. So signal is not going to unlock anything. So I think we can just call it first and then send the buffer. Yeah, this is the conned wait. Sorry, signal is a conned broadcast. So that just tells people that we are in the process callback. But actually, we probably want to just check the mode here. So if we are in sync mode and the cycle state if we're not waiting and in sync mode, if we are waiting, we signal with true, which means we wait for the accept. Yeah, so if we are in cycle waiting, we set the cycle active. Set it to active, which means we are in the process callback, and then do the signal, so it will get out of that. And now we're active. So this is the handshake. And that means that we should have a buffer now after that. So then we set it to inactive after that. Unconditionally. And then we want to if stream, if we have a buffer, pending buffer, then we do the PW stream. Stream queue buffer. Stream, and then it's we basically grab that buff, buffer, we queue it. Otherwise, it's stale. So we just throw it away in that case. Is that even possible? Shouldn't be, because that should only happen for dequeued buffers. So you queue the buffer, and then we do another signal, I guess. So the only erase that can happen there is that if we are if we're in this loop wait and we do a signal, then we do a signal and it's not active, so it just puts it back into waiting. So that's fine. If this went too fast, that means that that's just gonna go to the loop, but because we are not active, actually no, because this is gonna lock the loop, so the loop is locked here, so this function can't even get called at this point. Is it possible for the signal to... Is it possible for this to... like the accept function to be called, and then this to grab the lock before the thread continues. And it's going to waiting again? I'm not sure. I'm not sure what the p-thread guarantees are for like signals and stuff. Let's assume it's possible. So if we are signaling the thread, if we are accepting, let's say we are I think then we don't want to set it to inactive here because this could clobber another waiting. We basically, when we enqueue, we set it to inactive here. And then we don't want to do this here. If you have pending buffer, then take it and assert that we have a PipeWire buffer, queue buffer. And then I think we just signal again. Because in the other modes, we're just waiting for the buffer to be queued. And it's fine to do this in funnel sync mode because if we were signaled, the worst that can happen is that this went into the loop again early, before this got a chance to run, which means if this is a signal, it can, like, it might go into waiting mode. And then this will signal it, but because it didn't set it to active, that's fine. It just loops again. Sets it to waiting again. And then once it gets here again, it'll work. I think the logic makes sense here. I think this makes sense here. Okay. Oh, it's Dick Programmer. Sorry. I'm just reading the chat right now. If you return from a process with a blank buffer, you get extra runs. Yeah, I know. Wait, a blank but yeah, but I don't think you want to ever enqueue a blank buffer for video though. So yeah, an extra run is what you want when there is no video frame, I think. Or is there a way to? Is there like a specific like stream. Yeah, this is all using the PW loop thread function, so I'm relying on that for the convar and all that. There's queue buffer to queue buffer. Yeah, I don't think there is a function to like tell it there is no buffer. I think you pretty much just expect the next run in that case. For video, this is video, remember? So, EQ it fed with zeros and the capacity requested and queued it back. Yeah, but I mean, for video, that doesn't make sense because zero is like a black frame. You don't want a black frame. You just want a dropped frame, right? Which is an X1. So I think an X1 is what you actually want here. I think that's the only thing that makes sense. Oh, this is funny. Dequeues a buffer. It dequeues as many buffers as it can and then requeues them. Oh, wait. Is this... Oh, I think this is how they're fixing the bug with the... Is it? It's looking for the... No, that doesn't make sense. Okay, it queues the old buffer. But... Wait. This is basically grabbing all the buffers until one is... Wait, what? Until it's out of buffers? No, I'm making a producer, so and this is not a portal. This is not portals. That's the interesting part, right? So, but it works the same as the PipeWire portal stuff. So this is a producer, a video producer. But I'm ready. What is this thing? Why is this in this demo? What is this demo? This is video. Oh, video input stream. Hold on. Oh, it's an input stream. Okay, that makes sense. Sorry, this makes sense for input streams. Video. USB source. Yeah, so this one process just dequeues the buffer and then does whatever and queues the buffer. That's pretty simple. Yeah, all of these are synchronous. So yeah, I don't think that's an example that actually has that. So I think this should actually work. And then the last thing I need to make sure is that the driver stuff is done properly. Basically what happens is that if we are in async mode, then we can be a rate driver. So the consumer only consumes at the rate of the producer. There's a stream flag driver. We can always be a driver. If the other side is not a driver, we can always be a driver in the in double buffered and single buffered and sync modes. If the other side is not driving, then we end up with the funnel set rate stuff. So there's a problem with single buffer mode. In single buffer mode, if the process function is being driven at like say 60 FPS, then we actually, yeah, single buffer mode might not actually make sense, because in that case we are blocking in dequeue until the previous frame has been sent to the consumer. But at that point, that frame is sent, and it's not going to... Hold on. Does this make sense? It waits for the frame to be sent. Yeah, so it's actually still double buffered because the frame has been sent, but you still need to grab another frame because I'm still busy. It's just different. And the two modes actually behave the same when your loop hold on, so you consume a frame, starts rendering. Yeah, in double buffer mode, you'd be one frame ahead, yeah. I think this basically needs a little ASCII art here to explain how it works. It's a little complicated. I think it needs better diagrams than this. But it does make some sense. Basically depends on how fast the consumer consumes stuff. Okay, I think this is fine. And let me just double check that I am doing all the signals in the right places so the sync mode can never get blocked. So if you call, if you call return, we definitely need to, say there's no buffer. Wait, assert no stream pending buffer. What happened there? Yeah, so in destroy, we definitely want to accept and make sure it's inactive and all that. In stream stop, and actually in destroy, we want to just stop it first, just make sure. And then that'll do the inactive thing. And that also means that that will do that will call the so that dead thing should be checked in more than one place. You definitely want to check that in queue and in queue. So I don't think I'm gonna have any callbacks. Wow, that's blocked anyway, so... But might as well do it just to make sure. Make sure we reset the cycle state here for all the weird cases. Actually, if CTX is dead, I can just make sure. This happens on encore error, so it should never even be callable while the other thing is blocked. So I don't think I need to even check the. I don't even do an accept here. It's just EIO. Because if it's dead, it's dead. So if it's dead, I do want to return a buffer. Just to make sure that we free it. But then EIO. And I also want to check that it's active. So if it's not active, we want to just return the what we said before. Like E shut down from the same from NQ in this case. And in this case, we also don't need to do the accept because if stream is considered inactive, we already do that. So we can just say E shut down on this one. If it's dead or inactive. And then, reconfiguring, and there's nothing actually. That's not locked, so oh, that is already checked here. Yeah. I think that makes sense. And what do we have left? on command, because process, trigger process, and process, do all this stuff. So about the driver thing, we can always be a driver. But we need to check whether... Do we need to check something? No, you already have the timeout stuff set, so I think this is fine. The only thing is that we need to be able to ask... Like, the OBS side, if this is running in... hold on. How does the negotiation for this work? Streams. Why are you producing a video of this? Is for like the VTuber stuff, like the avatar. This is for video sharing between applications. So as far as I know, the way this works is that the PipeWire, essentially every video producer is expected to be a driver, I think. Because they, like, the subgraphs for video are generally not connected to anything else. But like the OBS built-in PipeWire stuff expects the video source to be a driver. But I need to figure out this lazy stuff. So lazy scheduling. Since stream is driving, content is driving. And service process. Yeah, so this lazy scheduling stuff is what I think we want. Either that or just have OBS be the driver. What's the stream flag trigger? You said who's the driver. That's the thing is I think multiple sites can be capable of being drivers. think this doesn't make sense. I think that you only want timeouts when you're driving and not lazy. Okay, there's a doc here that explains this. Yeah, so there's a priority, a driver priority thing, right? So PipeWire will, if multiple nodes can be drivers, then PipeWire will pick one to be the driver. So for lazy scheduling, a driver will wake up a graph. All followers need to process the data in sync. The cases where the follower might not be ready to process the data. Driver is not ideal. Driver might not know when new data is available in the follower. Might wake up the graph too often. Driver producer, no driver true is driving. And is not lazy. Calls trigger processor start the graph. Lazy producer supports lazy one. Is driving, is lazy. Requesting producer supports request. Not driving and is lazy. Emits request process. Follow producer not as lazy. Yeah, so screen sharing is the usual case that OBS happens, which is the producer, the driver, the follower is the consumer. Headless server requesting producer. The consumer requests new frames and the producer its refresh rate. When there are request process commands, this throttles the frame rate to the consumer but idles when there is no activity in the producer. So both are drivers, but the producer supports request, consumer supports lazy. Consumer selected as driver. Yes, that's not a case. Frame encoder, lazy driver producer, requesting follower consumer. Consumer pulls the frame when it's ready to encode the next one. Producer produces the next frame on demand. Consumer pulls the frame when it's ready. Next one. Yeah, this is basically our case. We want to support lazy, and we want to put supports request on OBS. So in this case, we are the driver, and the consumer should actually not be the driver because OBS is not, but that doesn't matter. But the important part is that this enables lazy scheduling. So what we want to do in OBS is support lazy and request frames when we render. Yes, that makes sense. Okay, so what we want to do is, how do we configure this? Lazy. So first of all, this was wrong. If you're driving and lazy. Wait, hold on. Timeouts if it's not lazy. So if we're driving and not lazy, then timeouts are active. Otherwise, we're not. So we only use the timeout stuff when we are driving and the other side has but actually no. We only use the timeouts when the mode here is not async. Because if it's async, we don't need the timeouts, we just produce our own frames. So if we are we don't have like an update timeouts thing. Oh, because we're gonna reuse this function. Update. Well, we have update timeouts there. Yeah, we want to just check those things here. So, put this stuff in update timeouts. And then we don't even need to keep that in here. Timeouts active. And just drop that. If the stream is driving and it's not lazy and the mode is not funnel async, then timeouts active equals true. So if we're driving and not lazy, and the mode is not async, then we want the timer. And then we also want to update the timeouts anytime the mode changes. Set mode. We need to set config pending in here. Update timeouts on stream. It's just stream. That might be redundant because we already called update parents, but it doesn't hurt to call it again. And then so now, how does the PipeWire config? How should it work for async mode and for? So for async mode, we actually wouldn't want to support lazy. But for all the others, we want to support lazy. So how do we do that? I think it's one of those props thing here. Yeah, supports lazy in configure. But this only happens on creation. Can this be changed? Supports lazy. You can do an update properties, yeah. So if we are doing update properties, and in this case, we never support request because we always want to be the driver if we are async. Let me just double check the scheduling. I mean, we could support the requesting where, like, if we queue a buffer in non-sync mode, we send the request. But does that actually make sense? I'm not sure if that makes sense. I think there's going to be a driver in that case. No, but if we don't, no, actually, it doesn't make sense to be a driver in that case. Does it make sense? I guess it would work. So in async mode, we know if we're not the driver, we could use request. So that's the other thing we need to do here also with the buffers. If we are in yeah, we need to configure this based on the properties. How do we do that? Yeah, so we definitely want to do a trigger process on in queue. Especially if we're async. Yeah, in async mode, we want to trigger process. Request process. Let me think about these modes. If we are... Yeah, essentially, if we are in one of these other modes, we could be a driver. But we want to have our driver priority kind of low so that if a consumer is interested in driving and not lazy, it could just take over. Yeah, so if we are the driver and in async mode here, you want to trigger process. And if we're not the driver and async mode, we still want to suggest... Yeah, so basically in async mode, we do this. Stream cur config mode equals funnel async. Maybe trigger process anytime you have a frame ready. And that already does the request thing. That does the magic. So does being a... Hold on. Go back to funnel C. Supports lazy, supports request. So first of all, can I actually replace these? Stream new props. What's the PW properties? Why is that different from a dict? Oh, it's just inside. Okay, and then there's extra flags. I have no idea what that is. Okay, so we want to configure these things. So if we are in async mode, in async mode, we support request. And we don't support lazy because it makes no sense. In double buffered and single buffered mode, we can support lazy and everything else actually. And we might want to set the driver priority so that we are more likely to be a driver if we are in async mode. And that was there's a thing that supports lazy too. Okay, so hold on. So if both sides are drivers, and lazy is greater than request, then the consumer is the driver. If both sides are driver and both are 1, now what's the rule? What happens if both are drivers and support request? If both are drivers and the two nodes have request and lazy, then if lazy is greater than request, then that node is the driver. So in async mode, we would say supports request equals 1. And then if lazy is less than or equal to request, then producer is selected as driver. No, we want to be the driver. So if we are, if we have request support, I'm confused. Laziest doesn't request. Then the node with lazy is selected as a driver. If lazy is greater than request, then the node with... No, that doesn't make sense. I think this is wrong. This is saying if lazy is the request, the lazy node is the driver, and this is saying if lazy is greater than request, the lazy node is the driver. That does not make sense. I think this documentation is wrong. What is actually happening? Okay, I need to read the source. Isn't this a massive project? Does it use open GL context sharing? No. This is using TMA buffs with PipeWire. Wayland only X11. No, it supports both. This has nothing to do with Wayland. There's nothing Wayland specific here. Here's the actual code. We prefer the driver that does lazy scheduling. Okay, so insert driver gets called on the driver. Notice the new driver. I think this is a sorted list of drivers. This is confusing. Priority driver. Pen doesn't insert into the previous. And previous is the list. The next is the list after. Next is the element, and the list next. Previous is element. Okay, so this will insert an element after the list element. And append will insert an element Am I hungry? Not much. Why? Tomato beef? Ooh, that sounds good. A little later. A little later. I'm getting somewhere. What? I'm trying to get the scheduling to work properly for this, so that like when a frame is sent, the thing that decides when that happens is the right thing for all different combinations of cases, because it's weird.
Did the triangle work?
Is it what?
Triangle.
Triangle?
Oh, you passed the triangle phrase?
Oh no, it's still still the triangle, but now I'm like
making it smooth.
Yeah, basically.
Okay. Any water?
No, I'm good. I had this.
I will steal yours.
Okay. Yeah, because the initializer is just a list pointing to itself, and then which I guess it means the list is circular, and that means that if you append after an element, then append to a list means inserting after the last element of the list, which would be previous. That makes sense. But then what is this doing? This is appending to the driver link of the node. Which is so what this is doing is it's inserting before is what it's doing. It's inserting before a very confusing function name. This is inserting before. So, that means if the priority is lower, then we put it before. So the driver list is the list of drivers in decreasing priority order. The editor is Kate. And then, if they're both no priority set, if they both have no priority set, then if the current node supports request and the other node so basically, of all the nodes with 0 driver priority, which is a little weird because then that means that only in the 0 case is this even considered. So anyway, if they both have priority 0, then if the current node supports request and the node that is being added supports lazy, and the previous, so basically this condition means this one gets priority. So if request is less than or equal to lazy, then the node with request gets priority to be the driver. Does this even make sense? Because if they both support request and lazy, so I guess that doesn't make sense to support request and lazy. So if we are the driver and we support request, wait, hold on. And priority driver, the priority is supposed to be, if it's lower priority, then we prepend. So if this condition is true, then N is deprioritized. So then the new node, okay, so when a new node is a driver and it supports lazy, and the driver with the lazy argument is greater than or equal to the request argument, then that node becomes the driver. So in this case, request, if lazy is greater than or equal, consumer becomes the driver. In this case, lazy also gets to be the driver. Yeah, this documentation is not right. If lazy is greater than or equal to request, then that becomes the driver. What does this say? So for a driver to not be selected, it has to be it's lazy has to be less than request. And also, this only makes sense if the priority driver is 0. But also, it doesn't support changing these properties. It doesn't update properly because supports lazy and supports request. It would have to remove and insert the driver to recalculate those. Yeah, so all this gets... This is what actually determines whether the thing is updated. And this happens when we calc graph. And it does a recalc. think I just want to set the driver priority so that in async mode we are like priority 2. Otherwise, it's like priority 1. Actually 0, I guess. Oh, okay. There's actually yeah. It's a thing that gets set on like the Elsa ones, I guess. This is a node on what? PipeWire dummy, like a dummy driver. There's a freewheel driver with less priority. Yeah, so Asta gets like priority 1. And then random like USB stuff gets more driver priority. Like MIDI bridge and stuff. Okay, so so wait, shouldn't the priority be the lowest one? I guess it probably is doing this is so confusing. Priority driver. Yeah, it is using the highest priority, but I guess it only works with nodes that actually are... If a node is linked in the graph, it would use that as a driver. So it would ignore the freewheel driver and stuff like that. So in this case, the USB audio interface is the driver. The driver priority is 2600, and in this case, the output was lower priority than the input. So the input gets to be the driver. I guess that makes sense. Does the graph have stuff like that? Yeah. Capture. OBS. There's actually nothing that is directly connected in this case. Okay, let's just try something. I don't even know what this USB audio analog stereo thing is. What is that? I know this. I know that. I have like a mystery USB device. I don't know what it is. What? What is that? Wait, what? Do I have a random Realtek plugged in that I don't know about? I'm so confused. Do I have a mystery audio card that I don't know about plugged in? What? Oh, sorry. I'm so confused. Why do I have a mystery audio device? I don't even know what it is. Huh? I'm so confused. What? Oh, no, I know what that is. I know what that is. That's the VR headset. That's the VR headset that's plugged into just this machine, not the whole thing. Okay. So that's a good test then. What happens if I just run a random, like, is there a SP something? Yeah, okay, random SP plugin, and it's just like a mixer. So if I just grab a mixer like that and Where is this? Here. Okay, so we take the... If we just do playback and we play this through the VR headset and the keyboard, so that's gonna make one of those be the driver, right? So here's the mixer, and the driver it ended up with is 78, and that is the VR headset, and this is priority 1109. Not MIDI. Is this output? Yes, output 1109, priority driver 11. Oh, they're both the same. Great. Well, that's not useful. But it did end up with 78. Okay, so if I let's just do the source. If I connect the if I connect an input, in this case, the driver ended up at 413, and that is this one, which has 2109 as the priority. So higher priority wins. Which makes sense. Okay, I'm gonna take a quick break. I'll be right back. I'm back. Okay. So the driver. I think what I want to do is in async mode, I want to set the driver priority to something greater than 0. So that ideally it is the driver if there is more than one possible driver. Otherwise, we just set supports request and supports lazy to whatever. Basically, if supports lazy is greater than or equal to supports request, then that node wins. So only if supports request is higher does that override who is the driver. So support request is higher, but the driver would be the one that is lazy. So if support request is higher, that means that it's more likely that that node will just be the driver outright instead of so we prefer the driver that does lazy scheduling. Unless the request driver so we prefer the driver that does lazy scheduling. Right, so that means that if you have just plain support request and support lazy, then ideally the driver that supports lazy scheduling is chosen as the driver, and then by definition lazy scheduling is enabled, so the other node will do the requesting. Unless the supports request node has a higher priority, in that case it would be chosen as the driver outright. This is a little weird, but okay. So I think what we want to do is, if we are in async mode, we want to ideally be the driver. So what's the default priority driver? There's a one for the mini bridge. How does it work with capture? If we just have let's actually do a screen capture. There's just no property. Okay. When yeah, so there's no priority. I guess the default is 0. Yeah, so in this case, we want the default of driver priority. Actually, I just realized. In the media stream, does this replace the properties or does it update them? That's another undocumented question. Why is PipeWire documentation so bad? So what this actually does in stream C. Okay, it does do an update with the dict. And then actually sets them. So there's no remove property, which is kind of annoying, unless PW properties update knows how to remove. Oh, null values. Okay, so if there's a null value, it removes them. So then does properties new support null values, or do you have to actually not have them? Wait, grabs the key, grabs the value. If there's a value and the key is non-zero, then adds items. So if the value is null, it does ignore it, which is what we want. And I can just get the dict from that. So, is this used anywhere? This does the whole update thing, but I can just do free. So in async mode, we support request. In the others, we can be a driver, but we support lazy. Yeah, that makes sense. Do we want this to be the driver? Or, more likely? I guess it depends. But changing the driver priority makes sense, because if you change the mode, then I need to do something to force PipeWire to recalculate. And it needs to be a string, so actually, and what is the priority driver thing? That's in... Key priority driver, okay. So do we want to support request in this case? If there's another driver, so looking back at the explanation of the graph stuff. Then yeah, the request does make some sense when there's someone that wants to be more of a driver than which would be the case with OBS if OBS were actually running the graph in its main thread loop, but it doesn't. Then you could use the request to ask it to send a frame when there is a frame in the producer. It does kind of make sense, yeah. If you are always running at a given frame rate and then you can make requests from the other one so that it's async. Okay. But then do we want to set the driver priority to higher? I'm not sure. The problem is that this isn't doing the driver removal and recalc. It's another bug in PipeWire, basically. So yeah, if it doesn't do that, yeah, I'm just gonna do it like this then. Yeah, I guess this kind of makes sense. Okay. So in async mode, we increase the priority. So we can be the driver if nobody else is driving. Otherwise, we can still be a driver, but we can support lazy mode. Lazy mode does not make sense in the async case because, like running the graph doesn't do anything. Yeah, okay. Let me just review this. Okay, I think this makes sense. In this case, we can just do props, and we can do the stream update props. Not params. Is it params or? No, update properties. The one clank format on this one. And that should be okay for the properties. Okay, and so then what we finally have is an enqueue. If we're in async mode, we trigger process, which means we either are driving directly here or we are triggering a request. And then the timer stuff, back to timeouts. If we are driving and not lazy and not async, then we enable timeouts. In async mode, there are no timeouts because we are requesting the driving from the other from the thing, and so then the other places where we trigger process are when we get the request process from someone else, where we're in lazy mode, and when timeout and here. Okay, I think that makes sense. And then finally, we just need OBS to actually support lazy mode request actually, and that's it, I think. So properties here. Stream news, stream properties. Where's stream properties? I also want to click format off on here. And so OBS will support request. And one more thing I want to do is make the double buffering thing configurable. And also, the double buffering thing only makes sense when we're not in lazy mode. Stream, do we have it? Is driving is lazy? Yeah, so if we are using lazy mode, which I hope updates also for the... Yeah, it should be updating for the whole graph. So we could check for that. So first we need to config setting here. Double buffering. All the stuff we added previously for the double buffering, that should be configurable. So we can add that, and we can always allocate the extra. Well, we didn't allocate. We just in the so if we have double buffering, we do this. If we don't have double buffering, we want to set double buffering. And then we need another bool in here. Double buffering. So if the stream, if we don't have double buffering, and the buffers are busy, we pop them. I think it's a little cleaner to understand like this. And that should be it for handling double buffering. We just need the set cursor visible. We just need the little thing here. Set double buffering. Enable double buffering, and then we want to have a little property thing here. Let me just copy that from the like that. And double buffering, and have another copy in here. And read double buffering there, and capture double buffering. And then here in PipeWire, we need to do the request thing. So in process, was there anything here that we're sending multiple properties? I think not. Anyway, we support a request for this one, and so the other thing we're gonna do is double. If we are double buffering, sorry, if we are not double buffering, if you're not double buffering, or the stream is lazy. Because if it is lazy, that means we are controlling the graph anyway, so we shouldn't be double buffering. Because that means when we present, we're gonna immediately request a process video, and then we shouldn't be double buffering, because otherwise it's just going to have extra lag for no reason. And then we just need the trigger process thing. And that should happen in the... actually in... It should happen when the video frame is done. And that might be a little bit tricky. We have the video take callback on new frame. But we don't want to... we don't want to trigger process... we want to trigger process essentially after all the frames have been presented. After they've all been presented, because oh, but then this is a little weird, because this means that if a new buffer comes in while we already presented one buffer. there's gonna be some tearing between the different renders. So we only pop present buffer when we get buffer when we have a new frame and the second buffer is busy. No, let me think about this again. If only buffer 0 is busy, then we have to get that anyway. If we are double buffering, oh, wait, hold on. Does that make sense? So we always present buffer 0. I think I did something weird here. Something doesn't make sense here. We have 2 buffers. We fill the first one, we can fill the second one. The second one can be presented anytime we... okay, that does not make sense. If we... When does video tick get called? It calls the tick callbacks. It calls all the source video tick. I think video sleep is the frame pacing part. Yeah, okay, so video time, so it's waiting after all the render stuff. What is execute graphics tasks? What's this video tasks thing? There's an OBS queue task. Oh, look, window capture plugin. Oh, but that just means it runs in the video thread. Okay, that's not exactly what I want. That's just doing the destroys in the video thread. Yeah, I think I basically want to run something when all the I think the renders had been done. Otherwise, I would have to request a frame at the beginning of the in get buffer. Basically, I could request a process. Yeah, this is a little broken. So, let me think about this. When you have two buffers, essentially we want to actually then the question is what happens with the graphics lock. What does OBS enter graphics do? Okay, does GS enter context? And there's a thread graphics thing, which is a thread local graphics too. Okay. If we have one and it's not current, it just leaves and then it's done. It locks the graphics mutex and enters the context. So then what does the video thing do when rendering? It enters the context while rendering displays. Render video, render main texture, Calls all the draw callbacks. That's called by output frame. So which is called by output frames. And there's multiple mixes, and yeah, so that's where does the context get entered here? Okay, that's where it enters the context. So it can be doing multiple things with it can be releasing the context lock in some cases. Technically, what we would actually want here is like a separate graphics context, and then just like share the textures. But that's, I'm not sure if that's even supported properly. So, I'm not even sure if it makes sense to prepare this buffer in the like outside of the video stuff, but I guess it's because it can block the PipeWire callback for a long time. Anyway, so the point is we essentially want to have the like a single OBS frame should use a consistent view of the video, which means we really need to get a buffer in here and then not touch it so we have a new frame is set on video tick. So first of all, we want to make sure that when we get a new frame, yeah, so presented is related to the there's two things. One is presented is used when we are when we're doing the sync object stuff, which is important. But we need a separate thing for presented, not just presented. We have busy, which means it has what's busy? Busy is true when we have data in it. And then we don't have drop presented buffers here because that just means it was presented once. We want a what we actually want is to know when the buffer is free, but we don't know that until the we don't know that until the next frame. So the single buffer keys is basically we grab a buffer in PipeWire, put it in the queue. The frame begins. We tell PipeWire to get a new frame because we have to. In the lazy mode. And then we are going to present the first buffer in the queue. So in that case, when we are doing lazy, we basically do if new frame then we do the stream trigger. And enter, we need the thread loop block stuff. Can this cause a priority inversion? So we are in graphics here. If we it is possible that the PipeWire thread is blocked on the enter graphics, which means that the thread, yes, this will be priority a deadlock if we lock. So how do I do this without deadlocking? Essentially, I want to be able to queue something in the thread loop without just logging it in line. This does a loop invoke. But it's doing it in the process callbacks as with everything already locked. Loop invoke. Is this what I want? Okay, so invoke may be called from any thread and multiple threads at the same time. I think that means we can do that. But these are already using emit event. The only case that doesn't do that is the no trigger thing. Which calls ttrigger on the node, and the stream node is what? What's this trigger thing? Trigger is... Ah, that's only if we use stream flag trigger, which I think we don't. Yeah. What is that? What is that supposed to do? Stream flag trigger. Yeah, we don't use that. So it should be safe to just call this. Okay, so when we first, if there's a new frame, we trigger a process, which means we are basically lagging by 1 frame. And that means that we do actually want to double buffer in this case. So then, while the process stuff is happening, we are rendering a new frame. And so then the other thing here is that if we are rendering a new frame and we currently have now what we really want is if we are in a new frame and the 0 was presented, then we pull 1 out. Unless if 0 was presented and we have a second frame, so if we already showed the first frame and the second frame is available, then we pop. The important part here is that if we receive 2 frames without presenting any, we will present the first and then the second, is the important part. So let me think about this. The frames arrive at some rate. It's possible to arrive. It's possible to arrive. Without any being presented. If to arrive without any being presented, then we are going to be presenting the first one and hopefully rendering fast enough that that we can pop it by the time the next frame arrives. Yeah, because then we should be able to catch up by rendering 2 before more frames arrive. Something like that. Okay. And then if we are not doing double buffering, we would just grab the latest frame anyway. Yeah, so we changed this. Yeah, this doesn't make any sense. We want to drop them in the presentation thread. Because we can't drop frames until we Yeah. So we are in graphics, so this is locked. This does not make any sense. We don't drop any presented frames because we might still want to present them again. So this does not make any sense. So the only thing is that it is possible to hold on. Get buffer. Okay, so we actually need another flag. Presented is just for the cleanup. We need a separate flag for essentially we need a state flag here. Buffer free, buffer buffer full, buffer presenting. Yeah, that makes some sense. So that's the 0. So it's actually, I think I did initialize that. And I probably need enter graphics around that, just to make sure that. Just make sure that if any of those functions are called from a funny thread, actually, when does this get called? The source is created here. Yeah, we have get width and get height. What are those called? Is that called from the only from the graphics thread, or is it called from somewhere else? Oh, it actually gets called from another thread. Okay, that's a little annoying. I think we basically need to cache these somewhere. Is it like an is graphics thread? Yeah, there's an is graphics thread. But that's not useful. Yeah, I guess I can just check if it's an task. You okay? No. Oh, that looks good. Put it over there. Can you make some space for there? Okay, I think what I want to do is check to see if we are in the graphics thread. If we are, get buffer. Otherwise, just whatever. And then I basically need a cache of the crop stuff. What's that called? OBS Dance Graphics. And then there should be a lock, trivial lock in here somewhere we can use. Is there a simple like lock primitive we can use? Without, I mean, it could just be pthread, I guess. Want a static. So I want a mutex in it, in here. Stream destroy. That needs to kill the lock. And then just lock that. And then that also should probably be locked. Because that's gonna come in from the format negotiation. Yeah, that comes from that, so that should also be locked. And I think I can probably just do that. Put the width and height somewhere. And I guess in that case we probably just gonna do this and get buffer. Do the frames have dimensions? They should. I guess this is just using the width and the height. Because you have an unremoved buffer. That just removes the PipeWire buffers when those are removed, but it keeps the stream buffers. So then when the dimensions change, we're gonna lose the PW buffers. So in get buffer, yeah, we should probably cache the resolution in here. In the present buffer. Well, we have that in the texture probably. Yeah, we have those, so we should just use those. me grab the buffer. And hopefully those are not... don't require any funny locks. Actually, they might. Yeah, those are fine. Okay, so there we go. Now we have an actual cache there. Same with buffer flip. No, that one you actually need to get the transform. And we don't need this anymore. We just need this. Get buffer flip is only called in render, so that we can just get buffer. And we have the PB in there. If we don't have a present buffer, return. If we don't have a texture or a PipeWire buffer, return. That means something wrong happened. And then we can do the buffer status. So we don't have the presented anymore. We have the state. PB state. Should be at least presenting in this case. And we set to present it. So if get buffer returns a buffer, it better not be free. Okay. So now in get buffer, what we do is, if we're not in graphics, there's no buffer. And also get width is the interesting one here. So we want to basically just update the buffer. And it has effective crop. Already does that. So and with this checking the transform, so we also need to cache that. It should be PB. We always use PB for this name. PB texture, PB transform. So width, zero, and then the thread. There's a lock. return. Okay, so this should be thread safe now. And let's see what else we have. So in pop present buffer, we need to check the buffer state. If it's less than presented, if it's less than presented, then we return that. So they start at buffer free, because I have a mem set in there, I think. Yeah, and then we need to set the busy equals true place. In here, assert pb should be free. And let me set it to full. Okay, so in pop present buffer, if current state does not equal to buffer free, equals free, assert next state equals free, and do nothing. If the next state does not equals free, then all that. Then it does the migration stuff. Otherwise, it just moves it over. Okay. So then, in process video sync, we don't drop any presented buffers here. Because we want to make sure the buffer is used, the consistent buffer is used for every frame. So we don't do that. So if the 0th buffer is not free, I have to then drop 1. So if it's not free and the next buffer is not free, then actually the question is what's going on with the presentation. If buffer 0 is being presented, if we have I might actually need 3 of these for some cases. Because the presented buffer is going to stay around until the next thing. The only the only question is that maybe we can just cheat a little here, and if the buffers are coming in too fast, we actually want to just drop 1 anyway. I think that's probably okay. I think that's not too bad. So now what I'm wondering if I need do I need 3 buffers to solve the double buffering issue? Essentially, the issue is if we have like I think if you have the present, if you have like a buffer here, right, and a buffer here, so what can happen is that we have like presentation can be like slightly off. So the problem I'm trying to solve is basically that like if we have this. Right? And so what would happen here is we get a buffer and then we present it immediately, right? Then we try to present the buffer, we run out of buffers. Nothing to do there. So there would be 1 buffer here in full. It becomes presenting. Then here we end up representing the same buffer, right? So slot 2 is still free. Then a new frame comes in slot 2. Then a new frame comes in, so then we actually need a new slot, because this is when we actually need 3 buffers then. Because this is when the, at this point, we're still presenting the old buffer. Basically, what I'm trying to do is make sure that this buffer goes here and this buffer goes to the next one. And then if the presentation happens a little faster, then you are... basically, you add 1 frame of lag when this happens, but you avoid like a jitter when the presentation and the source are not exactly... are roughly at the same rate, but not exact. But in this case, because we're presenting the same frame here, we still need to be able to cache 3 more. So actually, we need 3 buffers in this case. 면도ksai na. So now I need to change the code for the pop stuff. But then what I actually... No, okay, this doesn't make sense. But I actually want us to have a separate place where we put a buffer when it is already being presented. And then... Yeah, that makes sense. So what I need is a... Basically, we keep a separate place for the buffers to be presented. So, the only problem is the weird combining issue we have with the cursor. Yeah, what I basically need is a pop buffers. It's a call that like merges buffers, and then we call it on different buffers. So we'd have current next here as arguments. If the current state is free, assert the next buffer should also be free. No, that doesn't necessarily make sense. It does make sense. Just gonna pop buffer. Okay, I'm gonna take a very quick break. We're back, and hopefully this is making a little more sense now. Okay, we're back. sorry about that. I hit the wrong thing on the mixer. So okay, this makes a bit more sense. So if it's a new frame, we want to get rid of the current presentation buffer if we have at least one. So, if buffer 0 is not free, then a buffer presenting buffer buffer 0. And then if there's another one, then we just get that one. New frame equals false, and then the present buffer is just presenting buffer. Okay. And then the only other place this is called is in process video sync and stream destroy. Okay, so in stream destroy. I guess we can just have a destroy buffer in this case. But in this case, the pop present buffer, this is not necessarily true. So we can just do that. Destroy buffer cur, and then move it over. Destroy that. Destroy the presenting buffer. And then finally, the process video thing here, we just want to do the buffer. So what we do is, if 0 is not free and 1 is not free, buffer. And then we also need to check the double buffering thing. We can do it there. So this is where we don't want the double buffer. So if buffer 0 is not free and buffer 1 is either not free or we are not double buffering. We pop the buffer. And then so if we are not double buffering, then we can end up popping out a free buffer. So we go back to 0. Yeah, this makes sense. Actually, guess what? We're not double buffering. It should be a little different. Yeah, well, we're not double. Yeah, this makes a little more sense the other way around. Well, we are not double buffering because if we're not double buffering, we're gonna drop them all, even if we previously had 2. So while we're not double buffering and the 0th buffer is not free, This is important, so we clear the second buffer out. And we don't have this busy flag anymore. And now let's see how many compile errors we have. First of all, what is going on here? I think I broke that with the formatting. What's the include for that? p3.h, yes, p3.h. Okay. We don't need this anymore because we're just using the other one. Buffer full. Destroy buffer cur. It should be stream cur. Why is this even there? Yeah, I don't care about any of those. Okay. Okay, now let's see if this builds and runs and all that. Where was my... Okay, so run OBS. That did not work. Buffer does not equal free in render. Why is it trying to get a buffer that's not free? Because get buffer didn't check for that. If the present buffer is free, then we just return null. We don't get a buffer. We don't update anything. Okay. So now, can we actually do this? So what is broken here? Set queuing. All right, the test app is not updated for the diagnostics. Funnel. Okay, let's fix these. Wait, why is it still doing that funnel that each not found thing? I thought I fixed that. Why is it doing that? Oh, is it because dot dot? Because the Ah, the relative directory is all wrong. Huh. That's kind of annoying. Right. How do I get SP? How do I tell it to do that? Is there a way to configure this? I think so. Yeah, I think that's what I want. .90. Candy. How does that work? There has to be a way of making this work. I think it's not reading my ClangD file. Probably needs an enable config. That doesn't work. Ah, okay, it actually failed. Good. So it's reading that. Oh, why did it not set the completion style stuff? SP, why? Oh, I didn't copy that? Okay, so it is calling that, and then failed to find compilation database. It's looking for compile. Wait, what? Oh, it's built there. Ah. Huh? Oh, wrong place. Okay, that does read it. Wait, how are we end up in dev Spout to PW? Oh, because it didn't. Right. Ah, interesting. Okay. Now it works. Finally. Okay, good. That's much better now. So we also need final sync in this one. And we don't do queuing anymore. We need to set just set mode. Okay, SP dict. Take the address. There's no mode. It's just config mode, I think. Two of your arguments to get state. Stream error. I assume I can just not set error. Let me just double check. Yeah, okay, it doesn't care. And then return buffer. Two of your arguments. Okay, that seems to work. Let's just close. I have too many, what's going on there? I have too many command line tabs. Need more. Oh, interesting. Look, oh, there's a bug there. Okay. That's definitely, unless that was for the other stream. It might be a bug in the official plugin. Okay, and now we're failing on the funnel test EGL. Yeah, so set mode. If we are using driver, that's async. Otherwise, we're gonna try with a single buffered and then try all the modes. Let's try double buffered first. Actually, might as well do all of them even. And then the swap interval should be mode equals async. One, otherwise 0. Woo! Core dumped. Okay. I should probably just turn off the debug info stuff. Where's it dying? So there's no node because it's not created, and this is in a let thread and update timeouts. Which is already getting called from configure. I guess it's... yeah, on the state change, on reconnecting, it already tries to update timeouts. I guess I just need to get the state. it only should have timeouts enabled if the stream is streaming anyway. So so now we died in buffers dequeued greater than 0. Did I just forget? I think I just forgot to set that. Okay, there we go. And it's not showing up at OBS. Do we have a connection? We do have a connection, so this is actually broken. So what's going on the OBS side? We're getting buffers. We're not rendering anything. Find this buffer. Buffer new frame. Give up. Okay, so it's not even... Oh, so this is failing, okay. So then what task is this getting called from? I would expect it to be called from a graphics thread, but maybe there is a maybe there is something else going on. It is called from the graphics thread. So no, it is in the graphics. Okay, it is there. So there is no new frame. Hold on. the frame tick function's not getting called. Because I did not call it from here. Now we are getting new frames, but still not showing. Suspect the resolution is not getting set properly. We're not getting to available, so we're getting new frame, but we don't get a buffer. So there's no buffer 0. Prepare sync buffer does set it to full. Let's do print the drops here. Interesting. So I think I'm probably not returning buffers. Oh, actually, not even getting the process callback called. Oh, we're out of buffers. Okay. Yes, that means we're not returning buffers. Oh, I think I forgot the code to... Yeah, I forgot the code to return the buffer. No, it is here in destroy buffer. Sorry. It's in destroy buffer. Return buffer. Let's see what happened. Almost done, just debugging stuff. What? What's going on? You okay?
You haven't eaten.
I will eat soon. I'm almost done. Just need to debug this little thing.
I'll help you.
Help you what?
Debug.
A debug?
Yeah. Which pointer are you looking for?
No, the pointers are fine. It's just running out of buffers, and I don't know why.
Oh, got it. 頑張って。
Interesting. Looks like when we get a buffer, we're not clearing the previous one, the present buffer. Get buffer, got buffer, and then, why aren't we popping it? Buffer was free, got buffer. That does not make any sense. Oh wait, that means the current buffer is free. Okay, yeah, fine. But then the first time it should be free. The second time it shouldn't be free. Oh wait, if current is free, then we still need to do this. That's because now the buffers can have a different logic. Okay. And now buffer presenting. We need to change. Ooh, OBS studio crashed. We need to change the. Yes. The buffer state here. We set it to presenting. Ah, there we go. Now there's a triangle. It's an FPS because this isn't. So now we have to try the different modes. So first of all, we can double buffer. And it shouldn't really make much of a difference in this case. Then, this is the same as async mode. In single buffer mode, it died. Ooh. Okay, that is what I want. I think it just died in queue buffer. Sec fault. I need debug info on this one. Which is gonna take a while. Yes, this is a tool that takes Spout2 source and translates it to work in OBS on Linux and also other things, because it's also going to be used for native Spout2-like functionality on Linux. So let's see. Oh, this is going to take a while. And I just realized if OBS has 2 frames in the queue and 1 presented and we just have 1 more sending, then our buffer counts here are still wrong. What we want is in double buffer. Yeah, we need more. We need that because OBS can have up to 3. 1 presenting, 2 in the queue, and then we have 2. We have 1 queued and 1 being drawn, so 5. Which probably means OBS should set the hint to like 4 at least, the min to 4. I'm not sure if the negotiation for that does the right thing though. When is debug info D? Does it have a cache? Like, why does it keep it cleans it like every day, okay. That's what it is. Okay. Oh, interesting. I thought that was actually... I don't know. I guess it just runs inline in GDB. Okay, it's the client library is a separate thing. Yeah. So hopefully that will not expire anymore. Okay. I don't know what it's downloading. None of the PipeWire stuff is spamming the whole screen. There we go. So it crashes on reconnect or something. There we go. The buffer busy. I think that probably means we requeued a buffer twice. I suspect. Probably should just have a mem set here. Oh wait, post this video. Oh no, it's async. That's fine. Yeah, because the buffers were removed. Ah, yeah, right. Move buffer callback. This is broken. Anything buffer.buff. Forgot this. This is what's going on. Okay, there we go. So now it's running in async mode. And it works if I run it more than once. In single buffer mode. There we go. It's not dropping any buffers. And it synchronizes to the rate of OBS. In double buffer mode, you can actually kind of see, I think, that it's like a little bit different. that's a little ahead because it's in it's double buffering. And in single buffer mode, actually, it shouldn't make a big difference. Yeah, if both of those does that. In sync mode, it should be yeah, it still works. So now what I can do is change the angle thing to be a little more so every frame we do like quarter. Let's do an eighth. And then I kind of want to move the triangle to a corner so we can see better. To make it smaller, and move it like to 0.8 or something. It's a little more than that. 0.5. Okay, there we go. So that shows now the frame more easily. So I'll probably set the FPS much slower to make it more obvious. Integer FPS value, let's set it to 4 FPS. So now it's running 2 frames behind. If we do double buffer mode, it's still 2 frames behind. Okay, that's interesting. That's because we are waiting for NQ before we swap buffers. So we only show the triangle on the screen. Is not when it was drawn, is when it was. Yeah, so we let me change this around. But then single and double should behave differently because in yeah, so in this case, in Q, we'll block until the previous buffers. So we've already rendered the buffer, but not presented it. Otherwise, we are blocking in DQ. Okay, so because we draw it in between those, it doesn't matter. It doesn't make a difference. So what we actually want is basically DQ, then draw the triangle. No go to. If we have a buffer, then Q it. And we can swap buffers immediately. So now it's 2 behind. In double buffered node. Yeah. Now it's 3 behind. In single buffer mode, it's 2 behind, and in sync it's also 2 behind because it's not any faster. So now, where does this 2-frame lag come from? That might be OBS internal, though. Maybe that OBS is doing its own buffering, actually. So the still buffering doesn't do anything when the FPS is fixed, or does it? Okay, let's clear up this debug here for get buffer. Right. In this case, because we are triggering the graph from OBS, it's never going to drop any frames. So let's actually print the buffer that's being presented in the render call. Or even get buffer. So in this case, it's one behind. It gets a new frame. It's scheduling a process call, and then it gets a buffer, which is the previous one. I get the feeling OBS is doing like its own buffering. And it also has like an old buffer there left. It probably should have something so it clears out buffers when it's invisible, I guess. Yeah, so probably just drop all the buffers on hide. Maybe not the present buffer, because I think that can be called asynchronously, but certainly the other ones. Oh, and this is breaking and shutdown and recurs 0. So the shutdown thing is a little broken then. Who's calling loop wait? Tear down PipeWire. Loop wait load stop. It's this one then. I forget if thread loop is supposed to be stopped. You guys really need to wait in this case. It doesn't make any sense. Yeah, okay, so that fixes that weird error there. No, that still shows the old frame. Frame present. Let's see. Does it log when it's get buffer? Yeah, it's actually calling get buffer anyway for each frame. It's just not showing it. So we can check for that. Is there a stream flag for active? Or does it call show anyway? I'm not sure. Because it probably calls show anyway. So in get buffer, if it's not active, if it's not active, we can just destroy the presentation buffer. Okay, then it doesn't show the old frame anymore. Yeah, I think that there's probably at least one frame of buffering in OBS. Let's set the FPS even lower so I can see it more easily. Actually, it's set to 1 FPS. Actually, studio mode is interesting. Is it synchronized? Yes. Oh, that's an interesting glitch there. So it does actually, like, use... Yeah, it definitely does at least one buffer. Okay, so 1 FPS. So it gets a buffer, and then on the second buffer it renders. So let's put a log in here in the render function. Yeah, okay, so it's... No, actually, it's not doing any extra buffer. And so where's the extra buffer coming from? So it is actually getting a buffer. I think I need to see both of these side by side. Actually, I can even just run it in the same console. So when you start streaming, it new frame renders one buffer, then it renders another buffer, then it finally renders. So it renders one buffer, but it didn't get it. Why did it not get this buffer? That means my sync code is not working. Because it should be synchronously. Okay, so then it's a bug on my side. A bug on the sender side. So my sync code isn't working. This is the last thing I need to fix. I am running it in sync mode. In sync mode, is it really sync mode? It should be. So we have process. Oh, something is weird here. It's off by 1. My funny thing here is not working. The weird synchronization thing I did. So it's waiting for accept. Oh wait, except shouldn't be called here. Except shouldn't be called here because we are... This is the happy path. why is accept? I think there's something weird here. If wait for accept is true, then increase y is greater than 0, can't wait. Oh, but accept is always decrementing, so okay, I can't just call it anytime I want. Because it will it will just go negative and all that. So I need to actually check for that. Okay, that's why. Ah, there we go. Now it's just one frame behind, which is exactly what I want. Now it works with the lowest possible latency. And this one frame is required because OBS is not synchronously running the process callback with the rendering, so there's not much I can do about that. So that, yeah, there we go. So in single mode should be 2 frames behind, which we are. In double mode, it's still 2 frames behind. I think it's 3. Yeah, there we go. In double mode, it's 3 frames behind. And in async mode, it's apparently it's so faulty. What happened? Okay. Almost there. Oh, I think that's just my night SDGL thing. probably have some. There we go. And yeah, you just get whatever in async mode. And the other question I have is in async mode, is it going to be 1 or 2 target frames behind? So to do that, let's change the speed again to something slower. Actually, can I do the little trick? I can do a little trick here. No funny thing. We go to window decorations. No, this is in window behavior. Title bar actions. Mouse wheel change opacity. I can do this funny thing. There you go. Now you can see it's not lagging behind at all. So, when we are running in async mode, there's no extra buffering on the OBS side to worry about. However, if I enable double buffering, there should be. Or not, actually. I guess no, because it's 2 buffers from the source, so it's not noticeable. There you go. Okay, I think I'm gonna call it a day. We have a library that works. We have a PipeWire buffering that is pretty solid. It supports the lowest latency mode. Let me show you the in sync mode. We have you can see how it's just a little. It's like. It should be 1 frame ahead. Let me just make sure. Yeah, it's 1 frame ahead, right? In sync mode. And in single mode, it's 2 frames ahead. And in double mode, it's 3 frames ahead. Let's actually document this. There we go. Okay, that makes sense. All right, I think we're done. This cell looks very good. I just need to clean up the debug logs, and now finally, I think finally, next stream I can work on the Vulkan API frontend, and then plug this into Spout2 and see if that works, or maybe plug it into Godot or whatever other source we want to try. Okay, thank you all for coming. I think we are done for today. I should probably commit some of this to get at some point. But yeah, there we go. That's the idea. Alright. Hopefully I can find something to do. Find some time to work on this next week before the weekend, if I'm lucky. So I don't have to wait that long. Alright. Let me check the chat. Sorry, I haven't really been reading the chat too much. I've no, don't go there. I haven't been flying too much. Hi, thank you everyone. Thank you everyone. I think I don't see any major questions. Looks good. Oh, and thanks Super Mario for the super chat. How's Cyan doing? I hope she's okay. She might be a little sleepy. And I'm really hungry and really want to eat the dinner she made for me. So, how long have you been on Linux for? For a long time. Like probably more than 10 years. All right, thank you everyone. I'll see you next time. Bye bye.